study guide forum. Today we'll be looking at how to use a galvanometer to do two kind of work. That work is what? To um to measure the current flow, and then to also to measure potential difference. Now to do this, for the current, to measure the current, since the galvanometer has a limited reading, deflection is always mainly around very low. That should be something like just like from the question I have here, something like about 50 millimeter amp. So it's always low, and it cannot give you all the values. So for that reason, to make it get whatever you want, it depends on the kind of resistor you use. Most often, to do that, to make it record measure current, we normally use a very low uh, current this thing, a resistor. We use a low current resistor, a low current resistor, a low voltage resistor. It will help us to get what we want. So now to make it record the potential difference, we normally require high voltage, high resistance. That is high resistance resistor that with high voltage, high resistance power, that will help us regulate, control, or safeguard our galvanometer. Because the galvanometer, when low high currents pass through it, tends to damage it because of its inability to record high high currents as well as voltage. So for that reason, it's very necessary that you put something like this, a multiplier, to make it work effectively. So this high voltage, high resistor that we add to it in series, is what we call multiplier. While in this other one, in the galvanometer, when we're using it for current, the low resistor we add to it is what we call the shunt. So it will allow most of the current to pass through it, while the galvanometer will record a very limited current, so that it will still remain intact without being damaged. While this other one, because of the nature of the galvanometer, so a high resistor is put in series with it, so that it can protect it very well, so that the current or the voltage will not damage it. All right, now we are going to look at some calculations on how to do this work, how we're going to use that effectively. The first one says that a galvanometer, of a resistance 5 ohms, and a full scale deflection of 50 millimeter amp is used to measure the potential difference of 60 volts. Calculate the resistance of the multiplier. We're talking about this one. The resistance of this one, this is M, the multiplier, and then okay, let's see how we're going to do it. All right, let's go back to what we are doing now. To do the work, we know that the current in the G, that's galvanometer, is what? 50 milliamp, which is something as 0.05 amp. And then the resistance of that galvanometer is also 5 ohms. And now we are to record the potential difference, the volts. That should be the total voltage. We can say it's T. We have it as what? 50 volt, 60 volts. So, and this other one, the resistance or the resistor for the shunt is not, multiplier is not known. We put what? M, which is, we can make it question mark. But we know that the total current, the total voltage, we can get the total voltage with this formula, volts is equal to that total voltage is equal to arrow the current, because in this case the current that flows through them, through this galvanometer connecting with the multiplier, the current that flow through them um, remain the same. But what is different here is the the voltage. The voltage tends to be different. So now the next thing we are doing, okay, this is a total resistance. The current remain the same, the voltage, the total voltage and the total current have a resistance. Now to calculate this one, we don't know this, but we know that this total resistance has to do with addition of these two, the resistor from here and resistor from that. But the current is the same. The current are the same. And then what we do here, voltage, our voltage is, we know our voltage to be is equal to current, which is 0.05, and then total resistance is ROT. Then what we do here, 60 over 0.05, that will give us 1 ohms. This is what we have. So now to calculate this very one we are looking for, we know that this M plus that of the G will give us 1200 ohms. And we know that this other one, the resistance of the galvanometer is what, 5, plus the resistance of the multiplier, which we don't know, will give us 1200. So then we can subtract. If we subtract, we have the resistance of the multiplier to be 1200 minus 5. That will be equal to 1195 ohms. You can see how big this resistor, the resistor has to be. So now with this resistor, now when we connect it in series with our galvanometer, we'll be able to record this potential difference of voltage. Now let's go to the second question. Second question. Going to this second question, we say that galvanometer of resistance 5 ohms give a full scale of 50 milliamp. Calculate the value of the shunt required to make it measure a current of 10 amp. To measure a current of 10. So in this one, the current passing through them will be different because we need a low resistance. We need a low resistance resistor that we can connect to it, that will divert most of the current to itself, make the most of the current to flow from to its direction. So to do that, we know that the current in the galvanometer is what? The current in the galvanometer is the same 50 millimeter amp, which will be the same as this. So the volt resistance of G is what? 5 ohms. So now, since the current is different and we want to measure current of 10 amps, then the current of that will pass through the shunt X will be equal to 10 minus 0.05. That will give us If we subtract, we have 100, 0, 0, 5, 9, 9 of current. That is as a 9.95 ampere. That is what we have. So the next one we're going to do now, since we have the current flowing through it, what we're going to calculate the value of the shunt. We know that since what we are going to do now is that we know that the potential difference, the PD of the G is equal to 0.05 times 5. That will give us it will be 0. Let me use calculator this time. It will be 0.05 times 5. That is 0.25. That's the potential difference. Now, and we know that the PD across both is equal. That is to say, potential difference of what the shunt is equal to that of the G, which means we have to calculate the potential difference of this shunt, we have 9 times resistance of the shunt equal to this other one, 0.25, which is the potential difference across the PD. So what we do now is to get the value of this, making arrow S, that is the resistor of the shunt, the subject of the formula, dividing, we have 9 points. That will give us 0.05 divided by. So what we have is ohms. That is the resistor that we need to be 0.025 ohms. You can see that this one is very, very small. So that's how we can get this thing done. Thank you so much for coming this far. And if you have not subscribed, make sure you subscribe. Leave your question as a comment there, share and like. Thank you so much.